Hello, guys. Welcome to Ramta Solutions. Welcome to Mathematics Transformation Geometry. Today, we are looking at reflection transformation. Remember when we introduced transformation geometry, we said it is the study of geometric shapes or shapes and how they're changing their size, how they're changing their orientation, and how they are changing their direction. So with this one, it is basically concerned with, let me begin by saying it's concerned with shapes forming new shapes with a different orientation. Okay, let me say with a different orientation. Okay, with a different orientation. Okay, so this is a reflection transformation. Of course, it is the same as what was the other one? Rotation. Basically, we are saying the same thing, but what makes it different? So, what makes transformation, rather reflection transformation, different to rotation transformation is that with this one here, an object, okay, an object will be reflected over a line, creating an image. Okay, an object will be reflected over a line, creating an image or mirror. Okay, creating an image or a mirror. Okay, so this line, we call it a reflecting line. Okay, this line, a reflecting line, will be same distance, between the original point and the image point. What I say, original point or original image, it doesn't matter. Will be same distance between original object or point, it doesn't matter, or image. Okay, let me say original object or point. Let me see. This line, a reflecting line, will be same distance between original point and image object or original object. Okay, so this is what is happening here. So with reflection, you need a reflecting line. Okay, with the reflection, you need a reflecting line. So this reflecting line, it is an axis of symmetry. Okay, this reflecting line is the axis of symmetry. Okay, is the axis of symmetry. By that, what do I mean? Like I said, it means the original distance between the object and the reflecting line is the same distance between the reflecting line and the image. Okay, so this reflecting line, this reflecting line is the axis of symmetry. Okay, meaning if you were to draw a line between the object and the image, well, that line will divide the two into two equal halves. Okay, all right. All right, so yes, it is the axis of symmetry. Maybe I should proceed and say it is the symmetrical line. Okay, it is the symmetrical line. Okay, it is the symmetrical line. Let me just add that. Okay, now we are types of reflections we are going to deal with. Okay, types of reflections we are going to be looking at. Okay, types of reflections we are going to look at about 8 reflections. Number one, we're going to look at the reflection about the x-axis or on the x-axis. Okay, a reflection on the x-axis. We're going to look at a reflection on the y-axis. Thirdly, we're going to look at the reflection on the horizontal line. For this one, we have to be careful. On the horizontal line, I'm going to add information on this. On the horizontal line, the horizontal line will be when y is equal to k. So k is whatever number you can think of. You're going to see the examples later. Okay. Types of reflections are, maybe I should underline this, that we're going to look at. The fourth one will be on the vertical line. So the fourth one is on the vertical line. The vertical line, this is where we will be saying x equal k. Okay, so k is an element of a real number, guys, okay? Then a fifth one will be when you look or when we reflect on the line y equals x. The sixth reflection will be on the line y equals negative x, correct? The seventh one will be on the line y equals mx plus c, but here m will be equal to plus or minus 1. The last one, which is the eighth one, will be reflection on the line y equals mx plus c, but the gradient is no longer equal to plus or minus 1. Okay, so these are the kind of reflections that we are going to look at. 8 reflections that we are going to look at. So stay tuned. This video will be a long one, but of course a long one because it's going to have examples. Okay, all right, perfect. Now let's get into it. The first one, we said reflection on the x-axis. Okay, reflecting on the x-axis. So when we reflect on the x-axis, here what we are saying the x-axis is the reflecting line. Okay, the x-axis is the reflecting line. Okay, so what is happening here? Since the x-axis is the reflecting line, I want you to think of it in this way. So let's say this is your Cartesian plane, x-axis and y-axis. Do you guys see that? What's going to happen here? Y value will change sign. Okay, y value changes sign. Okay, so the transformation rule here will be if you have point A with coordinates, let's say x and y, the image will be A prime will be x value remains the same, but y value changes sign. Okay, this is it better if I use a red one? Yeah, better. So this is the rule. Okay, this is the rule for reflecting on the x-axis. I'm gonna try an example, of course. Okay, remember this rule here. So I'm gonna try an example, and in my example, I'm gonna say, whoops. In my example, I'm gonna say reflect A with coordinates 2 and 3 on the x-axis. On the x-axis, our expectations are A will be, remember A was 2 and positive 3. A prime will be x value remains the same, y value changes direction, changes the sign, right? Now, I'm going to show you in a Cartesian plate. So I'm going to put a grid. This one is not nice. I'm going to put a grid. Okay, this one is better. Okay, now let me use a Cartesian plane. Y values, okay, the yellow is fine. Okay. 3, 2, 1, okay, okay. All right, perfect. Now, this is the y-axis, this is the x-axis. So this is 1, 2, 3, 1, 2, 3, 4. Negative, 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 negative. Again, 1, 2, 3, 4. Negative, negative, negative. Of course, 0. Moja, mbili, tatu, nne, tano, sita, saba. Okay, I don't need sita, saba. All right. Now, let's look at it. We want to confirm if what we just said is correct or not, right? So the reflecting line, let me use a bigger font size. The reflecting line is the x-axis. So here is it. This is where our mirror stands. All right. This is where our mirror stands. Now we are locating the point that we have is 2 and 3. X value is 2, y value is 3. So here is it. This is point A, which is 2 and 3. We said the image is 2 and negative 3. 2 and negative 3. Here is it. So this is A prime. All right. This is A prime. So it's going to be 2 and negative 3. So now let me remove the grid so we can have a proper view. Now I want you guys to look at this. Look at the distance between the reflecting line and the original point. What is it? 1, 2, 3, isn't it? Now look at the distance between the image and the reflecting line. 1, 2, 3. And so the rule that we had is very correct. Okay, the rule that we drew is very correct. So if you reflect on the x-axis, y value changes sign. Okay, if you reflect on the x-axis, y value changes sign. Okay. Now, let's go to the second one. Second reflection we are going to look at is on the y-axis. All right, reflection on the y-axis. Maybe let me not be lazy. Let me write it in full. A reflection on the y-axis. Reflection on the y-axis. So with this one, what you should now imagine is this. The reflecting line is the y-axis, right? The reflecting line is the y-axis. Now, what is happening here? The x value will change direction, right? The x value, not direction, will change the sign. Okay? Will change the sign. So I'm just going to draw it here, not to use the whole space. Okay? So if you had a point here, if your reflecting line is somewhere here, the image will be on the other side. Okay? The image will be on the other side. And because this is a reflection, there should be equal distance between image and reflecting line, original and reflecting line, right? So as you can see here, the y value will remain the same, but the x value changes the sign. Therefore, the rule here is A let's say it has coordinates x and y, will then become a prime. X changes the sign, remember? Negative x and y. So this is reflecting on the y-axis, right? So what is our example now? Our example, I'm going to say reflect a 2, 3 on the x-axis. And by the way, guys, this information that you're seeing in video, you can also check it out on our website, okay? All right. Reflect not on the x-axis. Why am I saying x-axis? On the y-axis. Okay, on the y-axis. So what are we going to be saying? We're going to be saying as a solution, you know that we say the rule is xy will become negative x and y. So we can say a 2 and 3 will become a prime. X changes the sign, it will be negative 2 and y will remain the same. Do I have to draw a line for this? I don't have to draw a line because it's explained in the same way as what I did previously, right? So let me not draw a Cartesian plane. Okay, let me not draw a Cartesian plane. It's explained in the same way. Okay, perfect. Now let's then head to, I think, the third one. Yes, the third one was reflecting on the horizontal line. Was reflecting on the horizontal line. Okay, reflecting on the horizontal line, we're gonna say y equals k. Okay, we're going to say y equals k. Okay, so with this one, remember what is happening here. Y equals k is a reflecting line. Okay, y equals k is a reflecting line. Okay, y equals k is a reflecting line. And I must say to you, this k is a constant. Okay, this k is a constant. Okay, and I also want to say to you, it's an element of real numbers. So whichever value you can think of. Okay, whichever value you can think of, as long as it's a real number. Okay, perfect. So with this one, it is slightly different to reflecting on the x-axis, right? It is slightly different to reflecting on the x-axis, because what is happening with reflecting on the x-axis is basically to say we are reflecting on y equals 0. Okay, this is the x-axis, and then on the y-axis it's basically to say we are reflecting on the x equals 0. Okay, so now reflecting on the horizontal line, we are basically saying you are reflecting on the horizontal line. Y is no longer 0, but now y is equal to k. Okay, so what is happening, if you recall, I said there should be similar distance between the original point and the reflecting line, and the reflecting line and the image, right? So this therefore tells us that, you know what, if you look at it, we have to consider, if you recall, when we're reflecting on the line y equals, when we're reflecting on the line, when we're reflecting on the x-axis, right? When we're reflecting on the x-axis, if you recall, let me just add a simple remark here. Let me use a small font size. When we were reflecting on the x-axis, we realized that y value will change the sign, if you recall. So we have this rule here let me just write it like this. We had this rule here that said x value will remain the same, but y value will change the sign. All right? But now it's pretty interesting here because we are no longer reflecting on the x-axis, but rather on another line that is not the x-axis. Being it y equals negative value or y equals positive value, it doesn't matter. So what's going to happen here? Initially, I want you to imagine it like it's 0 minus y because it was on the origin where y value equals 0. But now, you're no longer on the x-axis. You are now thinking of a different value. If you recall, going back to the x-axis, okay, here is it. So if you recall, there is the same distance here, right? There is the same distance here. So k is 0. And this distance, if you can look at it, you can say this distance here is equal to this distance here. So we can therefore say this distance is basically twice. Right? This distance here between original and the image is twice the distance of original and reflecting light. Maybe we can call it 2k. I know Lonalema 2000, 2k. Right? So this k here is 0, which makes it 0. Hence, it is not surprising that we're saying x minus y. Now, let me go back to what we are doing right now. So here, the reflecting line is k. So what we can say, okay, here, the rule, we can therefore say if we have a with coordinates xy, the reflection will be a prime, x remaining the same, but y will become 2k minus y. Okay, y will become 2k minus y. Okay, where k is that horizontal line that you are reflecting on. You guys follow? Where k is the reflecting line that, or is the line that you're reflecting on. Okay, all right. Now I'm gonna give you an example. I hope you guys follow. So now, as an example, and for this one, I'm also going to show you a what do we call this? Graphically. Okay, a graphical representation. Example. Example, I'm gonna say reflect A with point 2 and 3 on the line. I'm gonna say on the line y equals 1. Okay, on the line y equals 1. So our solution, we will say, okay, here we can see k equals 1, sorry. So now we need 2k minus y. What is k? K is 1. What is y? Y was 3. As you can see, y is 3, right? So 2k minus y will become 2 times 1 minus 3 is negative 1. Therefore, we can say a 2, 3, when reflected on the line y equals 1, will become a prime with coordinates 2 and negative 1. Now, let's prove this. I'm going to use a grid. Okay, I'm going to use a grid now. Let's prove this. There we go. Okay, is this enough? I want to believe so. I'm not sure, but I think it's going to do. Okay, I think it's going to do 4, 3, 2, 1, 0. That's fine. Yeah, it does. It can work. Okay, though I don't need a lot. Okay, so this is the y-axis, x-axis 0, moja, mbili, tatu, negative, 1 2 3 4 positive, 1 2 3 4 5 positive, 1 2 3 negative. Right? Now, let's start. Our point is x value is 2, y value is 3. Here is it. Our reflecting line is y equals -1. Where is it? Okay, let me change the color. Here is it. Right? And let's now consider the distance between the point we have here. Point A is rather 2 and 3. The distance between point A and the reflecting line is 2 units. And the distance between this and the image will also need to be 2 units. So it must be, A prime must be 2 and -1, isn't it? Indeed, this is what we got. Okay, this is what we got. Okay, this is what we got. Can you guys now see that indeed this is working? Right? So the rule we had is perfect. Let's go back to review it. To review it, what do we say? We say when we reflect on the horizontal line y equals k, we'll say the general rule is xy will tend to become x and 2k minus y. Happy? Great stuff. Now, let's go to the fourth one. Remember I told you guys this video will be a bit long. So the fourth one is reflecting on the vertical line. All right? So reflecting on the vertical line. For this one, I'm not going to use the graph anymore because it's the same thing as on the horizontal. Reflecting on the vertical line. So here we will say where x equals k. Right? X is no longer 0. Okay, x is no longer 0. Okay, so what did we say previously? Here, x equals k is the reflecting line. So x equals k is a reflecting line. Okay, x equals k is a reflecting line. All right. So just like we said with the previous one, remember I said this comes from, if you recall, reflecting on the y-axis. If you recall, reflecting on the y-axis. So we had xy will give us, y will stay the same, but the x value will change the sign. You guys recall, right? It is the same thing here. So here, the rule will be, did I say A? Oh, yeah, let me just say A. I'm using point A arbitrarily, guys. You can use any point. Point A, let's say x and y will create A prime. Now, because you're no longer reflecting at x equals 0, you're reflecting at x equals something else. You're going to say 2k minus x and y. Do you guys see this? The very same explanation I used in when we were detailing reflecting on the horizontal line is still applying here. Okay, it's still applying here. Okay, you guys follow? Perfect. So now let's now try an example, and if you guys like, let me not draw a graph because the same graphical procedure works for this one as well. Okay, as was with horizontal line, but maybe let me just draw it. Okay, so we'll just do it to be consistent. Now, example, reflect A with coordinates 2 and 3 on the line x equals -1. On the line x equals -1. So our solution, we said we're using this rule here. Right? We can see k equals -1, isn't it? You can see k equals -1. So this therefore says 2k minus x will be, what is the value of k? We just said -1. What is the value of x? It was +2. So this then becomes 2 times -1 minus 2 will become -4, isn't it? Yep. So we can say, therefore, a prime is -4 and 3, isn't it? A prime is -4 and 3 because y value remains the same. Now, graphically, let's show this graphically. Even if it's big, this one doesn't matter. Oops. Okay, so because I need to move a bit to this point needs to be a bit long. Okay. Here. So this is y, this is x. Bedi taro. 1, 2, 3, 4. Moja, mbili, tatu, nne, tano, sita, saba. I hope I'm right. And then in 2, 3. Okay. Okay. So our point is A, which was 2 and 3. 2 and 3 is this one here. Our reflecting line was x equals -1. Was x equals -1, which is this one here, isn't it? Was x equals -1, which is this one here. So graphically, let's now count the distance. By the way, this was point A, coordinates 2 and 3. Distance between A and the reflecting line is 1, 2, 3. So we also need to move 3 units to the left of the reflecting line, right? This is x equals -1, by the way. So it'll be 1, 2, 3. Hence, it is not shocking that we getting -4, A prime, by the way, -4 and 3. Exactly what we got here, right? This is exactly what we got here. Do you guys now see it? This is your transformation reflection geometry. Okay, on the line x equals 1. Let me go fix something there. I do see I didn't say here y equals. I didn't write this equation. Is y equals 1, right? Perfect. I hope so far you guys are enjoying this, right? I hope so far you guys are enjoying this. This is indeed a reflection geometry. So we have a lot to do. Now we're going to move to the line, the fifth one. I want to believe so. The fifth one is reflecting on the line y equals x. Reflecting on the line y equals x. So here, y equals x is the reflecting line. Okay? Is the reflecting line. A tip for this one: simply swap the values around. Okay? Simply swap the values around because you are solving for x and solving for y. Simply swap the values around. Okay? For this one, simply swap the values around. Therefore, the rule, if you have a, let's say you're saying x and y, A prime will be to simply swap, meaning it'll be y and x. That is it. Okay. That is the rule when you're reflecting on the line y equals x. Okay. That is the rule when you're reflecting on the line y equals x. Okay. Happy? Perfect. Now, let's go back to our example. Remember our example, we will still use that one, A, 2 and 3. Reflect A, 2 and 3 on the line y equal x. Of course, our solution for this one, remember, we simply swap. A prime will be, rather, A is 2 over 2 and 3. A prime will be just swap, whereas x becomes y, whereas y becomes x. So it'll be 3 and 2. Now remember what I said to you. I said the distance between the point and the reflecting line must be the same. So we are going to prove that. Okay, let's go. So we're going to prove this graphically. Okay, let's see. Okay, I think this is perfect. Okay, cool. All right, so we need, remember it was 2, 3, okay, 2, 3, so it shouldn't be too long, but it won't matter. And then we don't need a lot of negative values. It's okay. Okay, and then let me just place the values here. This is 1, 2, 3, 4, 5. I can stop there. Pedi taro nne tlhano thataro, still stop there. 1, 2, 3, 4, 5. I will stop there as well. Then moja mbili tatu. I don't need much. Okay. All right. All right. Then we need a line y equals x. That is to say, where with this line, where x is 1, y is whatever. So we can say, let me see, 3. And we'll start at 3 and negative 3. So if x equals 3, y will be 3. So this is, I need a reflecting line. So where x is 1, y will be 1. Where x is 2, y will be 3. Just like that. Okay, so this is the reflecting line. Okay, I'm not sure if it's correct because I see it looks a bit awful. Okay, let me slide it down a bit. I think it's better. It does the way. Okay, so we have the point A, which is 2 and 3. Where is it? Here is it. A. I'll have to use a different color. Let me use this one here. This is A. I'm going to say 2 and 3. Now, I want you to pay attention, okay? I'm going to give you the image using the grammatic reflection or the grammatic representation. The distance, horizontal distance between the point and the line is 1 unit. So this is 1 unit to the left. I will need to move 1 unit to the right. Right, so 1, 1. So this point is somewhere here. But just hold on. Again, this is, again, 1 unit down. So I also need to go 1 unit down. Do you see this? But now when you look at it, you ask yourself, but this somehow does not really make sense, isn't it? It somehow does not make sense. So then what does that mean for us? I'm going to start it afresh. Okay, I'm going to start it afresh. So we're looking for the y value. Remember I said you move 1 unit to the left, 1 unit to the right. So let's see. Here is it. This point looks like it's a bit far. Going there, it will mean I have moved 2 units to the right, which is not correct. So allow me to look at it in this way. 1 unit to the left, all right? 1 unit down. So what do I need to do now? I'm going to say 1 unit down. Here is it. I'm going to go 1 unit down and 1 unit to the right. Okay, so the new point image is here. Now let's look at it. Let's look at this image. Oops. Now let's look at this image carefully. When you look at this image now, where is it? It is a prime has the x value 3 and the y value 2. Once again, how did we get it? Oh, you moved 1 unit down. Okay. Then 1 unit to the right, isn't it? So, oh, okay. So this means even this one has to move 1 unit to the right from the line and then 1 unit down from the line. So if this is moving to the right, this must move to the left, and this was moving up from the line, this must move down from the line. Okay, hence we're getting 3 and 2. Okay, hence we're getting 3 and 2. Remember the line was y equals x. Okay, the line was y equals x. Indeed, we got a prime to be 3 and 2. Now, let's go to the next one. The sixth technique is reflecting on the line y equals negative x. Is that so? Yes, reflecting on the line y equals x. Okay. Reflecting on the line y equals negative x. So with this one, what do you do? Solve for x and y. So we can see y equals negative x. But what is x? X equals negative y. Okay, what do we do then? This therefore implies that the rule here is if a prime is x and y, if a is x and y, a prime will be, what is the value of x? As you can see, we said it's negative y. And then what is the value of y? We said it's negative x. Just like with y equals x, but this one, they are all negative. This is the rule. Okay, so this is the rule. Okay, now let's go. Example. Oops. Example. Reflect A with coordinates 2 and negative 3 on the line y equals negative x. What do we get? So we will say, A, so we will say in our solutions, we will say, we remember we need to use x and y, giving us negative y and negative x. Okay, so therefore, this means a prime will be, what is negative y? Negative y will be negative 3. What is negative x? Negative x will be negative 2. This is a prime. Now, let's do it graphically. So the graphical representation Ooh, okay. Okay, doesn't need to be too low. Okay, this is fine. Okay, now let me start numbering. 1, 2, 3, 4, 5. Negative, 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 negative. 1, 2, 3, 4, 5. Negative, 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 negative. Nngwe, pedi, tharo, nne. Nngwe, pedi, tharo, nne, tlhano, 0. Okay, so we are reflecting on the line. Oops. We are reflecting on the line y equals negative x. So if we are reflecting on the line y equals negative x, it will be quite interesting. If y is 1, y will be negative 1. Okay? So just like that. So if y is 4, x will be negative 4. Okay? All right. Now let's go. We will start here and then pass by the origin, just like that. Okay, perfect. So we say this is y equals negative x. The point that we have is a, which is 2 and 3. Where is it? 2 and 3. It's this one here. This is point A. Let me use a different color. A, 2 and 3. It's this one here. Now, let's now begin the maneuver. From here, we move 1, 2, 3, 4, 5. I hope you paid attention. 5, ne? 5 units, right? So this one's 5 units. All right, now let's see. 1, 2, 3, 4, 5. Again, 5 units. All right, 5 units. You will need another 5 units. 1, 2, 3. Okay, here is it. Here is it. The 4. The point that we are looking at is here. And what is it? It's x value is negative 3. Y value is negative 2. This is A prime. Let me remove the grid. Do you guys see it? Indeed, this is what we found. Okay? This is indeed what we found. And this is reflecting on the line y equals x. We have 2 more to go, guys. We have 2 more to go. Okay? Perfect. Let's go now. Now, reflecting the 6th one. The 6th one. Is it the 6th or the 7th? Hold on. Oh, this was the 6th. Now we're going to the 7th. The 7th, reflecting on the line y equals mx plus c, but gradient is either positive 1 or negative 1. Okay, but gradient is positive 1 or negative 1. Okay, so this means you can say y equals x plus c, or y equals negative x plus c. Okay, so with this one, simply solve for x and y. Okay, simply solve for x and y. Okay, so I don't really want to give you sort of a rule, but if you solve for x and y, you have it. So for this one, I'm sorry guys, I have to just give you an example. Okay, I have to just give you an example. Can we? All right. Example. Reflect A with coordinates 2 and 3 on y equals negative x negative x minus 1, whichever you choose. Okay, so what we are going to do now in our solution, this is what we're going to do. We can see y equals negative x minus 1. We are good, but we need x value, isn't it? So what is it? So this implies x equals what? Negative y minus 1, isn't it? So now let's get it. So this means y equals negative 2 minus 1, which is equal to negative 3. All right? In the same way, x equals, let's see now, x equals, what is the value of y? 3. So x equals negative 3 minus 1, which is negative 4. Therefore, we can say a prime is, what is the value of x? Negative 4. And what is the value of y? It's negative 3. This is you reflecting on the line y equals mx plus c. It's done in this way. Okay, if the gradient is 1 or positive 1, simply solve for x and y. Now, to do just this, we will have to do a graphical representation of this, right? It's gonna be interesting. Oops, not on this page. Next page. Okay. Okay, that's fine. So I saw some, I think, let me do this. The Japanese at here. 5, 4, 3, 2, 1, 0. Okay, this is fine. All right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Nngwe, pedi, tharo, nne, tlhano, thataro. Nngwe, pedi, tharo, nne, tlhano, thataro. Okay. All right. So remember our reflecting line. Here, our reflecting line, by the way, our reflecting line was y equals negative x minus 1. So I want you to now think of it in this way. Y-intercept is negative 1. Oops, I forgot to put the negative. Y-intercept was negative 1. Y-intercept was negative 1. Where is it? It's this one here. And then x-intercept will be, will also be negative 1. So just gonna take these guys here and say, let me see, move you. Can move you like this, buddy. Move you like this, buddy. Move you like this. Okay, perfect. Okay, yeah. Okay, that's it. So this line here is y equals negative x minus 1. All right? All right. Now, let's go back to show this point. Point A was 2 and negative 3. Where is it? Here is it. 2, not 2 and negative 3. 2 and 3. Here is it. A is 2 and 3. Now let's look at the distance, vertical and horizontal, between A and the reflecting line. 1, 2, 3, 4, 5, 6. Use a different color. So this is 6 units. Interesting. 1, 2, 3, 4, 5. Again, this is 6 units. Interesting. 6 units, right? We then gonna need 6 units there. This is also gonna be 6 units. So the point A prime, it looks like its x value is -4, y value is -3. Let me remove the grid now. So we just found x value to be -4, y value to be -3. Is this corresponding to what we had? Yep. Do you guys see that? Indeed, this corresponds to what we had. Okay, so we were able to prove this, right? We were able to prove this. Okay, we were able to prove this. So this technique goes for when you're reflecting on the line y equals mx plus c when your gradient is either positive or negative. You will do these things. Okay, so I've shown you analytically how you can solve this and graphically how you can solve it. You good? Perfect. Let's go to the last one. The eighth reflecting on the line y equals mx plus c. Now this is when the gradient is not equal to plus minus 1. This one, guys, it's different. So the method here, one, find equation of the perpendicular line. Okay, find the equation of the perpendicular line. 2, find point of intersection of the two lines. Of the two lines. 3, use midpoint to find image. Okay, use midpoint to find image. By now, if you do not know the midpoint, let me remind you. The midpoint theorem, not the midpoint theorem. The midpoint between 2 points can be given as, let's say, capital M with will be x1 plus x sub 2 all over 2 and y sub 1 plus y sub 2 all over 2. That's the midpoint, right? Oh yeah, that's the midpoint. Okay. So with this one, we need to just get straight into the work. Okay, we need to get straight into the work. So let's see. We will say, let's see now. We will say, example, reflect, reflect A with coordinates 2 and 3 on the line y equals 2x plus 3. Okay, on the line y equals 2x plus 3. I don't like this one because graphically it's gonna demand, but it's fine. We will try. Okay, so our solution, equation of perpendicular line. Equation of perpendicular line First thing first, gradient of perpendicular line will be negative half, isn't it? I will just show it here. So gradient of perpendicular multiplied by gradient of the line must be equal to negative 1. Okay, so obviously this gradient here is 2. So 2 times gradient of perpendicular line is equal to negative 1. Hence, we have this one here. Okay, all right, perfect. Now I'm gonna use this formula here. Y minus y sub 1 equals gradient of perpendicular line multiplied by x minus x1. This line, the perpendicular line, will pass through the point A with coordinates 2 and 3, isn't it? So we use that point. So we'll say this is y minus y1 will be the value 3. We said the gradient of the perpendicular line was negative half. And then x1 will be the value of x, which is 2. Okay, so we have, oh, by the way, remember guys, you can use any form of equation of a straight line you like. Even if you use y equals mx plus c, it's still gonna give you the same thing. Okay, so then this is y minus 3 equals negative half x plus 1. Therefore y equals negative half x plus 4. Happy? I believe we are now good, right? We are good, right? So this is equation of the perpendicular line, right? So this is the equation of the perpendicular line. Let me see how I introduce this. Okay. Number 2, point of intersection. Point of intersection. Okay, how do we write intersection? Yo, point of intersection. So we'll say y of this perpendicular line is equal to the line that's given. So this is negative half x plus 4 is equal to, the given line was 2x plus 3, isn't it? 2x plus 3. What we can do, first and first, let me simply say minus x plus 8 equals 4x plus 6. So I multiplied throughout by what? By 2. Okay, so we can say minus 5x equals minus 3. Okay, so minus 5x equals, or let me put it like this, I think it'll be moving too fast. Minus x minus 4x will be 6 minus 8. Is it better? 6 minus 8, isn't it? Perfect. So we have minus 5x equals minus 2. Therefore, x equals 2 over 5. Isn't it? X equals 2 over 5. Now, substitute this value into either equation of the perpendicular line or the given equation, whichever you like. So let me just use this one here. I'm gonna use this one here. Y equals 2x. What is it? It was 2x plus 3. So it's gonna be, so let's see. This looks like 19 over 5, right? Okay. So therefore, y equals 19 over 5. So point of intersection is what? 2 over 5 and 19 over 5, isn't it? Okay, so this is the midpoint of, so this is the midpoint of original point and the image. Okay, so 3, what did we say? Finding image. Right? So midpoint to find image, midpoint to find image. Again, a reminder, the midpoint, we say x sub 1 plus x sub 2 over 2 is equal to y sub 1 plus y sub 2 all over 2. All right, now we're going to use the x value of the midpoint will be equal to x sub 1 plus x sub 2 all over 2. What was the x value of the midpoint? It's 2 over 5. 2 over 5. And then x sub 1, let's say it's what's given. The given point was 2 and 3. Okay, so it's 2. We don't know what is the image. Okay, so what do we do? Multiply throughout by 5 and multiply throughout by 2. Will be 4 equals 10 plus 5x sub 2. So what do we have? We have negative 6 equals 5x sub 2. Going to the other side, this therefore implies x sub 2 is negative 6 over 5. Negative 6 over 5. Isn't it? Negative 6 over 5. Now, the y value of the midpoint will say m equals y sub 1 plus y sub 2 all over 2. What was the y value of the midpoint? It was 19 over 5. 19 over 5 equals y value of the given point was 3, right? It was 2, 3. Yes, it's 3. Plus, we don't know the y value of the image. So multiplying throughout by 2 and multiplying throughout by 5. 19 times 2 will be 38. I want to believe so. So this is 38 equals 15 plus 5 y sub 2. Then this will be 23. 38 minus 15 will be 23 equals 5 y sub 2. Therefore, y sub 2 is 23 over 5. So y sub 2 is 23 over 5. So a prime is negative 6 over 5 and 23 over 5. Okay, so with this one, I don't like the graph, but you can do the very same thing that we've been doing all along. Okay, you can do the very same thing that you've been doing all along. Okay, and this, guys, is how you perform a reflection transformation. With that being said, it's a wrap and bye-bye.